Alright, so let's explore the domain idea again when we compose functions, but let's do one that's kind of challenging. Let's do one where we are composing two functions that are rationals and find out what to do from there. Okay. So if I want to compose these two functions to create a brand new one, and I start with f of x is equal to x over x plus 5, and g of x is 6 over x. So again, we're going to do f composed with g of x, and that's f composed with g of x, like that. In other words, the second letter, remember the second letter in what I'm doing is on the inside. Now the way that I like to write this so that I don't miss anything is, I know I'm evaluating the function f, so I'm going to rewrite my function f, leaving big parentheses in place of where these x's are. So I have an x in the numerator divided by x plus 5. This represents f of x. Now everywhere there's a parentheses, I'm going to go replace the parentheses in the parentheses with g of x, because remember, I'm evaluating my function f at g. So here I would have a 6 over x and a 6 over x. So we are going to then have to simplify this ugly looking fraction that we have going on here. It's not as bad as you think. What you want to do is you want to clear this of all fractions. In the numerator I have just this fraction, denominator I should say, and in the denominator I have just this fraction's denominator. So what I want to do is I want to multiply both top and bottom by this common denominator, which is just x. Okay, so I would multiply this and this by x over x, because that's like a 1 over, that's like 1. Well, when I multiply x times 6 over x, I'm going to just show you what we're doing over here on the side. 6 over x times x over 1. Okay, so this green x became x over 1. Now why did I do that? Because remember, if I multiply fractions together, I multiply numerator to numerator and denominator to denominator. So this x, which is a whole number, has to be written in fraction form, and we can write all whole numbers over 1. Now watch what happens to those x's. They cancel, leaving me with just 6. So that means that if I multiply 6 over x times x, what do I get? Just 6, because I just showed you that I did that over there. That's the point of this. I'm trying to multiply this ugly fraction by some value, which in this case is x over x, to get rid of those ugly fractions. Now what's going to happen in the denominator? Again, when I multiply x times 6 over x, I just get 6. And when I multiply x times 5, I get 5x. Now this is a much more reasonable looking rational expression than what we started out with, which was this ugly thing. But if you just multiply through to get rid of that variable, or to get rid of the denominator, then it's not that bad. So this is the function we are now dealing with. This is f composed with g of x. Now let's talk about the domain of this function. Well, we have two domains to consider. First, I have to consider the domain of the inside function. So the domain of g, well, g is 6 over x, right? Isn't that the function? G of x is 6 over x. And the domain of this guy is x cannot be equal to 0. So we would have to throw out a 0, because I'm not allowed to have 0 for x in that denominator. The second bit of that is we have to look at the domain of my newly created or newly composed function. Well, the denominator here is 6 plus 5x, and so we want to solve it for what values when I will cause the denominator to be equal to 0. So I have 5x is equal to negative 6, or x is equal to negative 6/5. So that's the other value I would have to throw out of this, because if I have a 0 to begin with, in the original inside function, I never really get out of that part to get to the second part of the functions because it's kind of like a two-piece part here. So then the domain is going to look like, if I can't have a 0 or a negative 6/5, let's draw our number line because this is confusing here. Negative 6/5 and 0. So I can have everything on the outside, in between, and on the other side of these two numbers. So my domain looks like negative infinity to negative 6/5 union, negative 6/5 to 0 union, 0 to infinity. That's how you find the domain on a composition function such as this. It gets really tricky when you have these rational expressions that you are composing, but this is the process that you go through.